Lessons concerning climate change. I'm going to look at a number of issues. It is going to not be short because I think you have to deal with this exceedingly carefully. And you have to have a biblical perspective, which I'm sure we all agree on. I'm sure I'm not suggesting any of you would think differently. But we do need to have a biblical perspective. And then when we come to the science, I think you have to be extremely careful because there is a number of issues. And my view may be wrong, and I'm not here trying to say, look, I know I'm right. It's just that I'm very skeptical, put it that way, that it's man-made. I find it very unsatisfying. I'm used to doing mathematics. I'm used to carefully examining assumptions. I was for a long while at the University of Leeds in what was then called at one time the Department of Fuel and Energy. Then we got absorbed into the School of Chemistry and Processing. But we were taught very much, and indeed I sought to teach my students to actually carefully analyze problems and work out where the assumptions are. Locked in with this is, and I don't tread here lightly, but I have to mention it, locked in with this is a perspective on the age of the Earth. Now I know we're not in total agreement on that, but let me say this, your view of the age of the Earth does affect the way that you look at climate issues. So I'm going to touch on that, so I know it's a delicate matter, and I want to be fair to my brothers and sisters who don't agree with my perspective. But what I'm saying is it has an effect. You cannot ignore it. So concerning the Christian and the environment, I want to make it plain that I'm very concerned about environment. If I put a doubt on the cause of climate change, that's not because I'm unconcerned about environment. I'm very concerned. It's not the most major thing I'm concerned about. I'm concerned primarily, as was mentioned earlier, for the preaching of the gospel. What changed Europe was God using Martin Luther, who famously said, "Here I stand no other on the scriptures." That influenced Wesley, it influenced George Whitefield, and my own nation of Britain was incredibly changed through the preaching of the gospel. America was founded on a sort of a nominally religious worldview, but what really changed the United States was the preaching of the gospel. So we need to be exceedingly careful that we put too much emphasis on something which is, yes, important, but isn't in the end the most important issue of all. But nevertheless, we should be concerned about the environment, and I've got a couple of scriptures here which has the original dominion mandate, as it's called in Genesis 1. But there are plenty of scriptures, I could have put hundreds more there, which talk about the principles of care for our neighbour and especially the poor. So when you've got issues like this, waste, effluents and noxious chemicals, of course I agree that it's a travesty that we should be pushing plastics into the ocean, where apparently some people say that, it's the size of a country floating there in the garbage in the Pacific Ocean. Of course that's wrong, and therefore we must have scripture and reason to deal with those issues from a Christian perspective. So in a large area, we agree with governments, and our own Queen has made a lot of statements, and Prince Charles, who will probably be king soon, the right things are going, he has made, quite rightly, statements concerning the environment. I don't agree with him totally, but I do agree with him on issues like this. And when it comes to the plastics in the ocean, I don't agree with landfill. I think it's not the answer. I actually in our own department at the University of Leeds. I've crossed over the Pennines now, and I've crossed over the War of the Roses to Lancashire, and I've realised just how beautiful it is. I live near Manchester now, so I'm no longer from Leeds. But if you know the history of my country, we had an awful War of the Roses where we were fighting each other hundreds of years ago. So I'm now living in Manchester. But when I was in the University of Leeds, we did a lot of work on incineration. And it's a great grief to me that people have made decisions not to incinerate at all, whereas actually you can incinerate and you can get rid of nasty gases by what's called scrubbing them. I won't go into that now. So, and of course, there is a Christian perspective on that. We need to have a Christian perspective. And that which really makes my blood boil, and this is where I really do agree with my environmental friends, is that to actually trade waste onto a poorer country is awful. To send by the ships that I no longer want to use and to have them cut up, producing horrible toxic gases, which probably shorten their lives by 50%, some of them, in India, is just dreadful. It clearly is wrong. You are exploiting the poorer nations. And so I have a large area of agreement. You know what I'm coming to? I'm coming, of course, to climate change. And I'm saying that just as you have got to have a biblical perspective on the environment, you must have a very, very careful biblical perspective when it comes to climate change. Now, climate change is actually not the same issue. Yes, it overlaps, but it's not the same issue, particularly when it comes to the cause of climate change. I'm not disagreeing that things have changed. They obviously have. I remember when winters were so severe. As I was living at that time in North Wales, we had feet of snow. And even in more recent years, when I was living in Leeds, when I went there initially, we had very harsh winters, but not so much now. It's evident that the climate has changed. Well, what I need to do then is to seek to obey that principle and to use scripture first. Always come from a scriptural perspective. And this is where I am going to touch on areas where we disagree, but I have a strong conviction in this area that when we read the scriptures carefully, there is absolutely no doubt that in the past, in my view, there were two major changes of climate. The first one is the worldwide flood. Now, I strongly am of the view, personally, that that was worldwide, because 2 Peter 3 verses 6 and 7 teach it, because it draws a comparison between the flood and the coming again of Christ. That, to my mind, settles it. There was a worldwide flood. And the flood was catastrophic. It destroyed the whole population except for 8 people. Now, there is absolutely no doubt that God brought that flood. And God changed the climate. Not only did he bring a flood, not only did it, in my personal view, cause most of the sedimentation, most of the fossils, not all, because there is room for post-flood fossilization as well. But that's my considered view. When I read the scriptures, 2 Peter 3 makes it abundantly plain that just as God judged the world in the past, he is going to judge the world by fire in the future. It's evident that the Apostle Peter is drawing a direct comparison between the worldwide event in the past and the worldwide event happening in the future. Now, the other thing is the time of Joseph, and I find this most interesting because in one sense we're a bit distant from the worldwide flood. It is a long time ago, somewhere in the region of 4,000 to 5,000 years ago. Some people would date it later, whatever, or earlier. That's not a big issue. It may be hundreds of years different, but let's not get involved in too much detail there. But what is that? What is perhaps a little bit closer to us in terms of sort of its dramatic effect is the time of Joseph, where you're not dealing with a nation which was God's people later, where you get lots of floods and famines because Israel disobeys the Lord. You're dealing here with a Gentile nation where God mercifully sent Joseph ahead, and he told through a dream to the Pharaoh, to the king, that there was going to be 7 years of plenty followed by, as you know, 7 years of disaster. Now, there is just no way around it that major climate change was caused by who? By God himself. That he is in control of Gentile nations and in control of kings, princes, and all nations. Well, you've got other localized changes. I'll just put this up, but I won't spend a lot of time on it. You've got the great famine in Canaan described in Genesis 12. You've got the time of Isaac, Genesis 26. You've got the time of Elijah. I only read this morning as I was having my personal quiet time. And I thought, wow, who only Elijah could pray, as it says in the book of James, commenting on this, and stop the rain. And then, you know what happened later? He prayed, and a cloud like a man's hand appeared. And he prayed again, and it grew, and then it became a great big, presumably thunderstorm of some kind, and he ran before the chariot, as you know, back to Jezreel. And that was just an incredible event. God is in control, and we need to remember these things. There are other times, the book of Ruth, 2 Samuel 21, and then I do want to just mention this, the future. This is the Lord himself speaking in Matthew 24, verse 7. I therefore appeal to you all to consider very carefully, whatever your view of eschatology. I'm not concerned as to whether you believe the details are different. I have convictions in those areas. But frankly, what is the major thrust of the New Testament is that the Lord is coming back. And he clearly says that nation shall rise against nation. That's happened for hundreds of years. Kingdom against kingdom. And there shall be famines, pestilences, earthquakes in divers places. It's evident that the Lord is also using the climate to remind us that he's in control. So I don't doubt that there has and is climate change. I don't doubt that there are issues of change of the ice cores, change of the ice cap, I should say, in both the North Pole and the South Pole, although there's some interesting things which are going on when you examine, in particular, Antarctica in a minute. So the North Pole is definitely reducing in its ice coverage. I've got to move on, but when we consider Antarctica, it's a very different story. There seems to be an oscillation of some kind, and although that's generally true, that graph, not all of it is true. Recent articles have shown that when it comes to Antarctica, there is really just a massive oscillation. And that overall, the amount of ice in Antarctica, the southern ice cap, is roughly the same in terms of its overall position. So, although the North Pole is going through, at this moment, a loss of ice, it would seem that Antarctica is just shifting. It's just shifting one from the western part with the peninsula to the east, or it may be the other way around, but it's certainly shifting when you actually analyze what's happening in Antarctica. And this is what somebody has said. Overall, the long-term trend of the sea ice is nearly flat. In 2013, 2014, 2015, Antarctic sea ice yearly minimum not only exceeded the 81 to 2010 average, they also exceeded almost all the values in the satellite record for that time of year. I find that an interesting fact. So we need to be careful about looking at the extent of ice when you look at both poles. Let me just make a comment. Let me make a comment on how do you make an ice age? because I'm going to be looking at the ice cores in a moment. How do you make an ice? It's a reasonable question to ask. How do you get ice such that it's covering virtually the whole, not quite the whole of the northern hemisphere, but certainly coming right down as far as Germany, coming right down as far as the Pyrenees, and covering a vast area in the north. We're not quite sure whether it covered quite as much in the south in a similar way. But one of the biggest problems that most climate theorists have is explaining how you get an ice age. It is not, I repeat, not by very cold winters. You need to grasp that issue. Because the issue is precipitation's got to increase. The moisture content of cold air is much less than that of warmer air. And less moisture in the air means less precipitation and hence less snowfall. So the answer proposed is the Milankovitch cycles. Well, if I just put up these pictures, forgive me, but I'm not going to dwell in depth on the Milankovitch cycles. Suffice to say that you could read up on them, look at Wikipedia. It's not always the bastion of truth it claims to be, but on this, it's just basic facts. That there is a wobble in the way the Earth moves around the sun. There is a wobble in the ecliptic plane. So there's a wobble in the angle made, and there is a wobble also in the actual orbit itself. It's difficult to describe all these, but there's a wobble in that orbit, right? So it's not always an elliptical orbit in the same position as it was, if you do believe in the hundreds of thousands of years that there was there before. So it's undeniable that there is definitely a wobble. But the trouble is that when you actually look at the Milankovitch cycles, I'm going to put up here another quote, even the paleoclimatologists, that's the climatologists who are looking at the climate in the past, admit that the amount of Milankovitch-induced change in solar heating is too small to melt glaciers or to send Earth into a deep freeze, unless some as yet unidentified part of the climate system amplifies it. In other words, Milankovitch is not the answer. And one needs to understand that because this is hugely foundational. I'm getting at the foundations of the way people are approaching climate change. No IPCC scientist would dare to doubt Milankovitch, but actually in writing they are. But the biblical flood is exactly the right scenario because there was much evaporation into the atmosphere. We don't know all the details, but we know sufficient to realize that when it talks about the fountains of the great deep, it probably, but I cannot say hand on heart I know because scripture doesn't tell me, but everything is pointing to the fact that there was massive volcanic activity going on under the oceans, heating certain parts of the ocean, causing evaporation, putting a large amount of dust into the atmosphere, therefore causing there to be the sun not appearing, not just for decades, but for a time leading up to centuries. Now, if you want to understand some of these issues, consider another year, which I think was 536 AD, where there was a massive catastrophe to do with Krakatoa. You have to look at some of the history on this because people didn't understand what was going on, but all the records show it. All the ancient records of civilizations at the time record that the sun just didn't have the strength, that it didn't appear properly, there was famines, the harvests failed, and it was all due to one huge explosion of Krakatoa in 536 AD. That's one major volcano, which in all the pointers are that 536 AD was a terrible time for most of Europe and most of the world. People died. Now, in the flood, you've not just got one volcano, you've probably got the whole ring of fire all around the Pacific going off together. You've got huge effects. And when the flood died down, and it took a year for Noah and his family and the animals in the ark to be in the ark, and then a year and 10 days later, they came out of the ark. Then you're dealing with a very, very difficult situation, which is why, by the way, there was a lot of extinction probably in this period. Not just at the flood itself, but in the immediate aftermath of the flood. Things were difficult, and everything points to the fact that there was a single ice age lasting centuries after the worldwide flood. And this has exactly the right perspective, no, perspective's the wrong word, the right ingredients to produce what I've put here, which is mild winters, so cold, but not desperately cold, so you've still got precipitation, and cool summers. And the ice would spread right across, as it did, the northern hemisphere. I've got a diagram here which might just help to explain it. More evaporation, much more than we've got at the moment in terms of world precipitation, increased snowfall, and relatively hot oceans. And just to bring a bit of further on the science here, if you want to actually just understand the issue of less precipitation when you've got less temperature, that's the graph that you'll need. But you can have a copy of my slides. Anybody can have them. I don't mind at all. And I haven't put them online at the moment, but I can organise that with Kevin Saylor. So let me now come on to the ice cores, because I need to spend a bit of time on this. The ice cores are, of course, particularly mentioned in this book. And I really do think all of us ought to read Michael Ord. He has done his homework. I'm not saying everything he's done is absolutely correct, but he's certainly done his homework and looked very carefully at these ice cores. He's an environmental scientist, that was his training, and he then has spoken often at creation conferences. And he writes here, with the blue writing here, who can argue with the simple counting of annual layers, the results of many variables, as well as the dating methods appear very consistent. And that's your initial conclusion. But the problem is that it isn't easy to count the layers once you start going very deep. And that's, of course, the area of greatest interest. It's all very well counting them for the last 200 or 300 years. That's not too hard. But once you start going very deep, you get this type of thing happening. You go from a snowflake to granular snow to what we call firn, not F-E-R-N, but F-I-R-N. And then you've got glacier ice underneath. You need to read this book to get the detail of what I'm now going to say. But depending on your perspective looking at those ice cores let me say that bit again. The way you approach the ice cores is going to be very much dependent on your assumptions about what I've just said, which is to do with age of Earth issues. So if you're a secular scientist, you say, well, of course, it's millions of years. If you come from one branch of the evangelical church, you'd be saying, well, we could deal with hundreds of thousands of years. And yet there are others of us who are saying, but just a minute, what about a worldwide flood? Where does that fit in? And of course, there'll be different perspectives of that. Not all of you here will agree with me. And I'm aware of that. I'm trying to speak with a courtesy to each of you because I know you come from different perspectives. But what I'm trying to point out is that your perspective affects your conclusion. And you must be aware of this. I have to be aware of it. And I'm quite open about my assumptions. I believe this book is absolutely right in 2 Peter 3. And I'm sure you do, but you may have a slightly different view. So I'm not saying you doubt Scripture, but that's the conclusion that I come to. So if you have a long age framework, then the calculated age of an ice layer versus depth is going to actually follow a curve a bit like that on the left. And then when you look at, and this is the important bit, when you look at the 18 isotope of oxygen, it's usually 16, but when you get this isotope of oxygen, it's, and I don't disagree with this, it's a measure, it's used as a marker of temperature. So the 18 isotope tends to go up with temperature, and that's used as a marker to try and work out what the temperature was at that particular time, okay? Now, of course, the secularists will say, well, this is over hundreds of thousands of years. These wiggles here represent Milankovitch cycles, and that's the traditional way of understanding it, right? But that's not the only way to understand it. There's a completely different perspective. By the way, you need to remember that, of course, time on that graph is going that direction because you're looking at the age of the layers. The other perspective is to look at it this way, which is that really what's happening is that you're looking at the amount of ice after the flood. And initially, a huge amount was laid after the flood in the centuries or so following the flood. And this changes your perspective about those wiggles. They're now all compressed in a massive area, which, yes, has, with all the weight of ice on top of it, that itself has got compressed. I haven't got time to deal with all that. I'm trying to give you the overall picture. But when you look at those wiggles are all in the time of the flood and post-flood activity, and it fits beautifully. In other words, all the variations of delta 18, which is the 18 isotope of oxygen, is primarily in that area. So do you now see that it's perspective and it's your worldview which is really affecting your interpretation of the data? And remember, time was going forwards on that picture, so I'm going to have to reverse it. I've reversed the writing as well. I haven't time to change all the writing, so forgive me. I'm deliberately churning it round because now what I'm going to do is I'm going to compress that, okay? And now I'm going to overlay that on what we had before. So now you can see the very different approach. Sorry, I went quickly through those slides. That this line is what the secularists are looking at concerning the layering of ice. But this, I maintain, my conviction, is the true way of looking at the ice. That most of it was laid immediately after the flood in one single ice age, not many ice ages. Now, of course, the secularists would say, when they looked at the delta 18 wiggles, they would say, oh, that's a time of an ice age. And then they talk about 30 ice ages. Well, let me just deal briefly with some of these issues. I can't deal with all the detail. I'm just trying to get to you the overall differences. And my main concern is that you understand that your worldview affects the way you interpret the data. I'm not worried about the data. I'm far more worried about people having a biblical perspective. That's really what bothers me most. But in terms of the science, does that show up then what worldview might be correct? Well, tentatively, and please don't think that I'm trying to come with a triumphalist position. I'm not. This is a difficult area. You have to pick carefully through all the data. I've got hundreds of books probably now on this issue because people have been asking me about it. And so I've decided to start speaking on it, even though, frankly, I'm more concerned about the gospel and getting people saved. But there again, sometimes you do need to deal with complicated issues. What I just want to show you is that this is a paragraph from Michael Ord's book where he says that one indication that the creation flood model is more likely is that the Greenland ice cores show only one ice age followed by a post-ice age period. Multiple ice ages do not show up. In the first ice core drilled at Camp Century, Dansgaard, that's a well-known secularist scientist, he does his homework, but of course he comes from a secular worldview. He hoped that the thin layers in the bottom several meters would represent several previous glacial and interglacial periods that cycle every 100,000 years or so, based on his graph of the ice layers. Such hope failed to materialize. On the other hand, the bottom of the ice core could easily be disturbed due to its proximity to the bedrock. Well, that's a fair comment. In other words, answering back that comment would be, well, when you're getting to the bottom of the ice core, it's meeting the rock, which is melting the ice, and we haven't got it anymore, right? Well, he answers that. Many scientists have usually appealed to basal melting, that means melting by the rock underneath, by geothermal heat or rapid flow out to sea for the missing ice ages. However, since the ice at the bottom of the concentric core is well below freezing, that would retard the basal flow, and Dansgaard, he himself, rejected these alternative explanations, thus admitting that only one ice age shows up in the concentric core in Greenland. Now that's a detail, but it shows you the type of issues that you have to face. That actually the data doesn't clearly show multiple ice ages, which is what they were expecting when they started doing this work in the 60s and 70s. It's just one ice age, which backs up what I've been saying, that when you take a biblical flood model, it fits far better. Now, I'm not saying triumphalist, we've solved all the problems, no way. But it does suggest that there is room here for scientists who come from a catastrophic mentality, that is, that the worldwide flood is the major issue, that there is a lot more work to do. I haven't got the money. Creation Christians haven't got the money to do their own ice cores. It takes millions of dollars to do that. But we can at least look at the data from others and carefully examine it. Here's another issue, significant issue too, concerning the ice cores. The ice sheet's surface undulations are a mirror of land surface thousands of meters below. Now that is a most unusual effect. Why is that happening? Because if you read these books, you'll find that the traditional view is that the ice is flowing and has flowed gradually over thousands of years, hundreds of thousands of years. And so the effect of what's right underneath should be felt, way down here, miles away, but it isn't. It's literally a vertical transposition from the land down below in Antarctica, this is, to the ice flowing above, which is not what you'd expect. Now, that's not a proof, but it does fit with the creation flood geology and creation flood ice cap approach. And this is issue number 3, which is that, and this is a more complicated point, I need to explain it. This again comes from Michael Ord's book. These are short period oscillations that you get in a typical year, right? And it's found in, if you go for layering, this is the rate of layering of ice at about 20 centimeters per year, which would be about what it is now. It might be sometimes up to that. Once you come below the Fern line, which is what I mentioned to you earlier, then the interesting thing is that you would expect all the wiggles to have gone if, in fact, you were going at the same rate over hundreds of thousands of years. Now, they know that, those who are looking at the ice from a different perspective, right, over long ages. Those scientists who believe in that know that that would disappear. So they say, well, we actually do find wiggles, so they must be annual layers. But do you see that if you actually assume a different outlook and actually say that there was a huge amount of ice laid over a short period of time, then the fact that you've got wiggles, a lot of them are actually sub-annual layers. So the point I'm making here is that a lot of the counting way down is actually going wrong because of the assumptions of the worldview of the people who are doing the counting. What they're counting as annual layers are in fact multiple sub-annual layers, because there's all sorts of storms that come through, dumping more ice, then warming a bit, then dumping more ice, warming a bit, and so on. So there are three major issues which come out of that book when I was studying this. And when the lot fell on me, I had to do quite a lot of study to actually dig out these things, which Institute of Creation Research have written a lot on. So now let me come to the issue of carbon dioxide and the issue of global warming itself. These, remember, are coming from those ice cores, so we have to be very, very careful, because, of course, I don't really accept these hundreds of thousands of years for my personal conviction, but some of you may. But let's just look at the data. Yes, it's true that it seems to be that the carbon dioxide is going going off the scale. Yes, it's true that it seems that warming is associated with it. I don't deny what was shown in the first talk concerning the analysis of carbon dioxide, which comes from Hawaii, where the CO2 is primarily measured from that. So this curve is certainly fairly well established. So I'm not doubting this, and I'm not doubting actually the global warming. What I'm doubting is that we've really understood what's going on. The carbon dioxide plots and the temperature are mentioned, of course, here in the Vostok Antarctic ice core, which I showed you earlier. But now let's just look at this in a little bit more detail. You must remember that the time, of course, is going this way. I'm deliberately mentioning this because there's going to be some plots where time goes the other way. So that's why I'm just reminding myself and you that that's what's happening. If we now look at the interpretation within the short time frame, I'm going to have us look again at the long age assumption look at that graph, right? Then I'm going to come back and look at it from a short-term perspective. Now, I'll tell you why I'm doing this. Remember, I said that time is going that way. But now I'm going to refer you to the papers of those who have actually done these studies. And this is a most interesting plot, which I'm just going to put all this up, if I may, and then I'm going to just draw your attention to it. This is looking at the peak in these graphs, okay, and it's looking at one in particular. I think it may be that one or that one. And it's looking at the peak, and it's showing that the temperature leads the carbon dioxide. This comes from the actual papers, which are in the literature and not written by people favorable to my position, okay? The temperature is actually leading the carbon dioxide. Now, that doesn't mean that carbon dioxide isn't a problem, and I need to be careful here. You could have what's called a feedback loop, where the temperature goes up first, then the carbon dioxide goes up, the carbon dioxide makes it worse, and so on, right? So I'm not oblivious to that point. But in terms of the records, I just want you to note that temperature goes up first before the carbon dioxide. So you cannot say that carbon dioxide is the primary mover. It can't be, not from the graphs anyway. So if we now, as I say, I wanted to look at this now from a short time scale perspective. So I'm going to move this on. If we look, we're going to, what does this roughly mean from the short time scale? So I'm really dealing with short time scale issues, noting that the temperature goes up first, admitted by those scientists who did the work, all right? Now I'm looking at this from a short time scale perspective, and I'm going to suggest that those times weren't correct, that roughly they're about 1,000 out. So it's about 1,000 in my terms wrong. Now, actually, there is something else wrong here. Remember I said that everything is bunched up together. It's a highly nonlinear. Remember what I showed you with the delta 18? So this is all still spread out. In my view, it's actually all together way down here, and then it actually settles down. But just for the sake of argument, I'm not really dealing with the issue of the one ice age following the flood. I'm just trying to get some perspective on the timescale of this temperature lead. We had it at 500 to 700 years. Actually, it's somewhere in the region of 5 to 7 years. Now, that makes sense to me. Because the oceans are a huge capacitor. Have we got a bottle of water here? Well, we haven't got fizzy water. But supposing I had fizzy water, and I had a fizzy water bottle, and I shook it up, right? That's one way of making the carbon dioxide come out. But another way is to heat it. And the carbon dioxide would come out. If you took the top off, it would explode, of course. So that is possibly what's going on with this. That's just a very crude recalculation because it doesn't take account of the nonlinearities involved. And as I leave ice cores, I just need to point out that there is a wonderful paragraph in this book, which I'm recommending that you read. And it's this is from an article. It's not from the book, but it's Michael Ord's. It's come from Michael Ord's book, and he's making a reference to it. Warm seas worldwide following the flood would provide optimum conditions for initiating the ice age. It would have been like lake effect storms greatly enhanced. That's what Michael Ord says. During this time, some snow would have been precipitated in the winter that would have melted in the summer. Consequently, the snow cover would have increased in thickness and lateral extent. And it's going on to say that that is a major issue when it comes to looking at the ice cores, that it was primarily laid down after the flood. And there's another little indication here of Michael Ord's work as he's working on the ice cores himself. He has done some work on them. So I am reliant on Michael Ord's work here in presenting this work to you. I need to hurry on because I want to get to a crucial point, which is what might be causing the warming. Now, you've all heard of the famous hockey stick graph, which is Michael Mann's plot. And fair enough, it's clear that temperature is going up. We're not denying that. But when you actually look at this in relation to what's happened in other times and in other places other than our own, it's a very interesting conclusion that you come to. First of all, other times. When we look back at what's called the Little Ice Age, which is in really medieval, just post-medieval times, then we see that we need to be very careful because, number one, you don't really know what the temperatures were. There was nobody actually doing measurements to the accuracy that we have now. But most people would agree that actually the medieval warm period before it was very warm. So although this is only estimated, and I do agree that it's open to question, people will disagree as to what the values were, but that it was considerably warmer. The records do actually show us that. Various records have actually indicated that there was a lot of warmth in Europe in the period before the Little Ice Age. So this is the Little Ice Age where you had winter landscape painted in 1608, and that's a little bit later than what I said earlier. And this is another one where you've got people, having ice parties on the lake and on the rivers. And certainly the Thames had that as well in England. So the correct temperature plot I'm indicating is that one, which then means that when we actually look back in time, when we look back in time, you've got a medieval warm period, then you've got a Little Ice Age, and then this is probably a little bit low. It should be a bit higher than that. I would accept that. And certainly this is not taking account of recent events. But certainly everything would indicate that we're not actually far away from what the medieval warm period was going through. So you don't often hear that mentioned by the BBC, and certainly the IPCC seems to hardly mention the real issues of the past climates. And when you go even further back to Roman times, there are records again which indicate that there was quite a lot of warmth, even in the Scotland, which gets pretty dire at times in terms of temperature today, but that it was much warmer in the past. There's references to vines growing in the, not the Roman times, but in the medieval warm period. And there is quite a lot of records which show this. So I would say that a lot of this comes, by the way, from a book called Evidence-Based Climate Science by Don Easterbrook, produced in 2016. As far as I know, he's not a believer in the Bible, but he does have a view which would doubt the consensus today. There's another book by a gentleman who's died recently called Robert Carter, who wrote the book Climate, the Counter Consensus, which is very useful. It's not making wild statements. It just simply says we need to check the data. Another book which is well worth reading is A Different Shade of Green by Gordon Wilson. That's more dealing with the environmental issues that I referred to at the beginning. But I do just want to draw your attention in a little bit more detail to what I said concerning the carbon dioxide lagging temperature. This is another detailed plot showing that and as I mentioned to you earlier, in my view, that it's a lag of about 5 to 7 years, but it just shows you that the temperature and the CO2 are actually displaced from one another, and it's very clear that they are. Now let me just say something in the closing part of my talk concerning some other issues which are very surprising. I found these very interesting indeed. The temperature of individual land masses as against the whole world averaged out. The USA, over a period, forgive me, I've forgotten what the period is here. Should say it on here. Yeah, it's from 1850 through to now. Now this is interesting. This is the contiguous USA, so it basically means the whole of the North American landmass, and it shows that correlates with, amazingly, the temperature change, which is, well, it's not the temperature change, sorry, the total solar irradiance of the sun. Now, whatever you think about the cause of global warming, when you start finding correlations, it doesn't prove things straight out. But it does mean that you have reasons to look carefully at what might be pointers to the cause. The Arctic also correlates with the total solar irradiance of the sun. China correlates with the total solar irradiance of the sun. Now, if you want the references, they're all there. I carefully worked them out here so that you could actually look at the original papers that these are referring to. It obviously comes from those who have written a different, the book Counter Consensus and other books that I've read. But I've tried to go to the source materials so that we're not just dependent on somebody's bias, which is often the problem, and that they have actually carefully got the data correct. So as far as I know, that I have checked that out, that they've got the correct graphs and that they have simply overlaid the two, which of course the IPCC has not done. Looking at the USA one, it's very evident then that as the carbon dioxide has gone up, which I'm not denying, there has been this correlation in the temperature of the landmass of the USA with the TSI, the total solar irradiance of the sun. Now, it's not the only thing which correlates with the total solar irradiance of the sun. We've also got here, this is a proxy for solar activity, so it's actually the production of carbon-14, which is linked with cosmic radiation, which is linked itself with lack of sunspot activity. So that's where that comes from. But it's recognized as a proxy for solar activity. You already know that the 18 isotope of oxygen is a proxy for climate change, for temperature. And it's amazing that this correlates with the solar irradiance, or the solar activity in this case, of the sun. I find that very compelling. I find all those graphs very compelling. They are telling me something which needs investigating. But as I said to you, there is other things which correlate with the total solar irradiance of the sun. A person who should not be ignored in this discussion is another person who has no friend, as far as I know, to the gospel, right? But he doubts the current consensus on climate change. He's an Israeli scientist called Nir Shaviv. And he says, he's written here, using the oceans as a calorimeter to quantify the solar irradiative forcing, published in the Journal of Geophysical Research. And you've got the reference there. Now, what he's saying is that there seems to be some sort of correlation between sea level change and the total solar irradiance of the sun, which is strongly suggesting that we do need to look at that. Because if you've got the oceans actually rising in depth as a result, possibly of the sun, or at least correlated with the sun, what's causing what, you might argue. I don't think you can argue that the oceans are affecting the sun, so I think it's got to be the other way around. But it could be that the sun is affecting something else, which is then affecting the oceans. It could be carbon dioxide is an amplifier in some way. I do accept all those points because we don't know enough. But when you actually, he's done some further work, and when you actually now take account of other effects to do with the oceans, the El Nino effects and everything, he gets an even better correlation. I'm running out of time, but I do just want to mention the IPCC. So when I see plots like this in the IPCC reports, I get worried, particularly when NASA, which is meant to be a little bit more objective than I think perhaps they are, makes predictions which, frankly, well, first of all, those plots I'm not sure are correct, particularly the one on the bottom. And when they make predictions about the temperature, and there is quite a disparity, when you actually work back and say, well, we got the data now, this is what the IPCC model would have done, and this is what we actually saw, then it does mean that we need to doubt our models. Because if the models, when we rework them, having got the data, right, so you go back and use the same IPCC program and run it now for, or you go back to what it was predicting, say 10 years ago, and then you find there's a big discrepancy, it's really telling you that we do need to rework our programming. Now, that's you might say it's an unfair point because all of us are going to make mistakes, and they all accept that there's a number of factors going on. But nevertheless, I think we do need to just be aware not only of the fact that there's a number of factors going on, but as I questioned earlier, what is the sensitivity analysis for each one of those factors? And in particular, I'm heading up to an important climax here. What is the sensitivity factor that the IPCC has put in for solar activity? It's very interesting what we find out. Okay, that curve, by the way, is not correct. It should have been more like that, but that's a detail. Look, I'm not going to, perhaps I should have taken that comment out because, frankly, it's only reduced it or increased it slightly. But you still haven't got a complete agreement between what basically, what I'm trying to say is that they didn't take account of total solar irradiance properly, and they didn't get their data correct. That's what I'm arguing there with NASA. But this is far more important. This is really where it heads. In the IPCC, there are a number of factors which they have in their programs, and this is the one I'm really concerned about. They have weighting or sensitivity factors which they put on carbon dioxide, on methane, which you rightly said in the first talk, Doris, it is 80% more effective per kilogram than carbon dioxide. I do accept that point. And then you've got other gases here, CO and so on, and all the rest of the aerosols, which is not unimportant. But when it comes to solar irradiance, they've just put a tiny, tiny effect. Now, I think we don't know what that weighting is, and I'm not saying I do. But the evidence is strongly suggesting that there is a correlation with the sun. Yes, greenhouse gases have an effect, and I'm not denying what Doris said earlier. And by the way, although it's an effect, we must remember that sometimes the effect is not built in of water vapor. So greenhouse gases in the atmosphere, the primary one is water vapor. Carbon dioxide is a small percentage. And when it comes to actually carbon dioxide itself, the amount that we produce is minuscule compared with what I've just shown you, which is about 3%. The US Department of Energy produced this table once and actually missed out water vapor, which they shouldn't have done. But so when you actually put the water vapor back in, which is now put in there, 95%, then you get what I mentioned earlier, the 3.6% effect of carbon dioxide. And man-made CO2 is only 3.225% of all CO2. So actually, the total effect of man-made CO2 is in reality, in terms of all the other gases and all that's going on, it's about 0.1%. Now, I'm not saying that that means that we should immediately start blasting everybody with CO2. We're not to worry about it. But it does mean that we've got to hold what we're doing in perspective. Yes, I'm concerned about climate. Yes, I'm concerned that others are affected by what we do, particularly in terms of waste and the other things that I mentioned to begin with. But I'm not convinced that it's CO2 which is driving everything. The temperature is certainly going up, but I don't think it's primarily us. The possible causes, as I'm now coming to a close, are to do with the solar cycle. It's very interesting that there is a correlation between sunspot activity and, of course, total solar irradiance. We know that. But how interesting that recent discoveries have shown that there is not just one 11-year cycle of sunspots. There is two cycles which are both about 11 years, just a few years difference between them. And I'm going to actually jump here because I want to close, but I do want to close with this point, that amazingly, there's a recent paper shown that the two solar cycles that I've just referred to lead to, of course, beating between these two cycles. When you've got two frequencies which are very close together, when they're together, they have a big effect. When they're apart, by 180 degrees out of phase, they sort of fight against each other. Well, what a recent paper has shown is that there is actually a centuries cycle going on as a result in the sun. And this cycle means, as this plot shows, that in our calendar year, roughly here, we're actually heading into a period of well, she maintains, of global cooling, the paper that this has come from. And she reckons that by the time we get to 2030, there's going to be a very, very different position to what we are now. So although I don't deny some of the issues that were mentioned earlier, there are some important differences between us concerning our perspectives for the future. So if I could just mention this is the paper, I think it's got it here. No, I haven't got the reference correct here. I apologise, but when I actually distribute it and give it to you to look at, I will make sure that I've got the correct reference there to the final paper about 2 solar cycles. But there is a recent paper just come out which actually talks about these 2 solar cycles and the predictions for the future, that it's actually leading to a time eventually where things will come in a cooling again, much like what happened in the Little Ice Age, much like what happened in earlier cold periods. So that, in my view, is what's going on. There is a very long-scale oscillation of the sun. But that's my conviction. I haven't proved it, but I think that's what all the pointers are suggesting. Thank you, ladies and gentlemen.